Light archaeology is territorial, stratigraphic, and non-destructive.
Urban transformations are by nature dynamic.
We were able to detect all the phases from the 12th century to the 20th century.
Historical transformation is a heritage value. We believe that the deep historic continuity in the city can and should link to its needs for multiple changes, ensuring that these changes are made by and for the people. That's why it's essential to understand the values people attach to the deep city, focusing not only on what we can see, but also on what we can feel, discover, uncover, and not see but experience. This is the Deep Cities Toolbox.
Cities are constantly changing environment over time, and they are transformed by the addition of building or of spaces, or the destruction or the transformation of use of these buildings and spaces. Through this process and through the interaction between the material layers and the people who live in the city, you have the building of layers that archaeologists are trained to recognize and analyze and interpret. With the Florence University, we are developing an approach that is also termed light archaeology. Light archaeology is a point of view. We consider the contemporary city as if it were an archaeological site. So from this perspective, we can use archaeological theory to describe the material changes and to put them together with social and non-material changes.
The stratigraphic observatory analysis is a particular archaeological approach that is dedicated to the analysis and the comprehension of the various transformation of buildings. We can consider 4 fundamental steps. The first step is obviously the identification of the building inside the actual urban landscape. For example, for San Donato, here in Florence, we have detected the church inside the modern urban landscape. The second step of this phase is the understanding of the stratigraphical visibility of the various aspects of the building in order to have a good comprehension of the history of the building. From this point of view, photogrammetric survey is very important for us in order to make a 3D model of the elevation that we have decided to study. The second subsequent step is probably the most important of the entire workflow, because in this moment we are analyzing and detecting and also mapping the different archaeological units that can be present of a specific elevation. We start with the analysis of the actual measures of the elevation and with the identification of the different archaeological units. Every single archaeological unit is numbered, and every single archaeological unit is defined and mapped using physical relationship with the other archaeological units. From the physical relationship of the different archaeological units, we are also able to understand the chronological relationship between the various archaeological units that we are able to detect. We usually use a recording sheet in which we make a sort of list of archaeological units made by the different number. Every single number, of course, is related to an archaeological unit. Every unit is also defined and described by a material point of view. And for every single unit, of course, we have also the recording of the different physical relationship and the chronological relationship. The chronological relationship can be posteriority, anteriority, or contemporaneity between the different units. The final moment of this entire workflow is the matrix areas diagram, an instrument in order to understand the various historical phases that are present inside my specific elevation, and every single unit, of course, is put into a chronological order related to the previous analysis.
Urban transformations are by nature dynamic, so every single event of change has a duration and might work as a trigger for further changes, planned or unplanned, in the long and the short periods. To understand deeply the history of a place and historical continuity is fundamental, then capture this cause-effect relationship and not mapping a single event of change, but the transformation as a dynamic phenomenon. The San Donato area in Florence is the perfect case study for a deep cities approach because it's a fast-changing urban area. In the last decades, a lot of transformation occurred in the San Donato neighborhood, but it is an area with a long history. We work with multi-layered reality, we work with a lot of layers of history and values. The Millennium Square Diagram is actually a snapshot of the material changes occurred in an urban area over a millennium. So you can actually see the transformation and their effects in time and space. The diagram shows on the vertical axis the time scan, a millennium. On the horizontal axis we have the space, percentage of soil occupation of each unit that we identified following the light archaeology methods. We talk about topographic units and architectural complexes. The Millennium Square Diagram of the San Donato area highlights the trigger of the settlement, which was the Roman road Via di Novoli. The area was used mainly for agricultural purposes until the 20th century. The very important moment of urbanization of the area was the erection of the Fiat factory, starting in the 30s and unavoidably had an enduring impact all over the area. It's important to say that the Millennium Square is a GIS tool, so it's based on GIS and on both primary and secondary sources.
Considering the city as a multi-layered reality, the city acquires depth under many different points of view. Thanks to the deep cities methodologies, we tested light archaeology also as an efficient tool for describing transformation at urban level in fast-changing urban environment. And the test was very positive, allowing us to describe this type of change not only in Florence, but also in our case studies of London Woolwich and Edinburgh Canongate. Thanks to the deep cities, we translated light archaeology from an academic tool into a planning tool that will be useful not just for understanding the past, but also for envisaging the new cities.